It's important that each image you present is an accurate visual representation of what you actually observed in your assay. When you misrepresent your data, you alter conclusions that the reader will draw from your image. While it is acceptable practice to adjust the overall brightness and contrast of a whole image, such adjustments should not obscure or eliminate any information present in the original image. Andy gave a very thorough description of saturation and how to avoid it on your Western blot. Because saturation occurs when strong signals do not accurately reflect protein levels, you should never attempt to quantify a saturated band. A saturated signal means that the instrument was not able to quantify the amount of signal that was produced from your membrane. So even if you are able to obtain a numerical value for that saturated band, the value does not reflect the true amount of the protein. Because the instrument was unable to accurately collect data from the membrane, the software should report the signal for that band as not a number, or NaN, or infinity. The software should not provide a numerical signal value. Your analysis software should also visually highlight saturation on your images. It'll typically be done by displaying saturated pixels in a different color. This may be an option for your software and should always make sure that it's enabled in your analysis. When you see that your image contains a saturated signal, either through visual inspection or quantification, you can re-optimize your protocol in order to avoid producing a saturated signal. For example, you can adjust your primary antibody concentration, you can adjust the sensitivity setting on your instrument if necessary, or you can image your membrane using an imager with a wider dynamic range. Because saturated bands cannot be quantified, it's imperative that you take the appropriate measures to avoid them. Just as having too much protein on your membrane can be a problem, there are also concerns when you have too little protein on your membrane. A good indicator as to whether the signal from a low abundant target comes from a real band on your membrane is to measure the signal-to-noise ratio. The signal-to-noise ratio is a measure of the signal for your band in respect to the background signal. This value will let you know if your band truly represents your target protein or if the signal is considered too low to trust. So although there's still some debate over what is considered a real band versus what is quantifiable, you can typically trust that your band is real when your signal-to-noise ratio is about 3 or more. So with this better understanding of the issues that can arise by having too much or too little protein on your membrane, we're next going to discuss some additional considerations for image adjustment and the important information that you should save each time you acquire an image.